Okay, this was the activity you guys were supposed to do yesterday after your quiz, but we really didn't have time. It's kind of a discovery activity, so I put it out so we could just do it together. As we start the square root unit, there's something about square roots that we kind of need to know. So it says use your graphing calculator. You're going to enter both equations into y equals and complete the tables given. So go ahead and if you have a calculator, enter your y equals x squared. So when your y equals enter x squared. If you need one, they're right here on the table. Okay, I'm going to go ahead and fill out our table for us. So we're just squaring the x values. Remember, when you square -2, it's a +4. So 2 squared is 4, 3 squared is 9, 4 squared is 16. And we're going to go ahead and we're going to graph that. So the quadratic sits on the origin. 1 squared is 1. 2 squared, or right 2, is up 4. Right 3 is up 9. And then it has buddy points, so you can kind of use that axis of symmetry to plot the points on the other side. And then draw it in. So that's the parent function for the quadratic. So it asks us about our domain and range. Who thinks they can tell me the domain? What do you think? Good. All real numbers, -infinity. Let's write it in interval notation since we started using interval notation. So soft parentheses for infinity. And then the range. Who thinks they can tell me the range? Good. 0 to... So it sits on 0, so we'll use the bracket, and it goes off to positive infinity. So after we graph that one, we're going to go back and graph the square root parent function, y equals the square root of x. Okay, so if you have a calculator at your y equals, you can type in the square root of x. And your calculator is going to tell you error, because you can't take the square root of a negative number. Okay, you can take the square root of 0. It's just 0. And 1 is the square root of 1. 2 is the square root of 4. 3 is the square root of 9. And 4 is the square root of 16. So what do you notice about the bottom half of the tables starting from 0? Yeah, they're opposite. They're just flipped. They're the same, but x and y's are switched. So let's go ahead and graph it. It sits on the origin. And the way that I would graph it is the square root of 1 is 1. So from my origin, this is my 0, 0. So I'm just moving right and up. So when I go right 4, the square root of 4 is 2. So back from my origin, when I go right 9, the square root of 9 is 3. And you can draw it in. Okay. Do you guys have a question? So let's look at the domain and the range for the square root function. It's a little bit different. So for my domain, it starts at 0, and it goes off to infinity. And then for my range, it starts at 0, and it's always going up a little bit higher and to the right. So the domain and range are the same. Next it says draw in the line y equals x. That's the parent linear function in red ink. So it cuts the graph in half in a positive direction. So there's my parent linear function. Okay, so what do you notice about the green and the blue graph? Now, I'll tell you that this is where my calculator is telling me error, because these are non-real numbers. So they're not really part of my answer for a square root. But what does it look like across that red y equals x line? Here's my y equals x. Here's my y equals the square root of x. It should look like a reflection. Okay, so this point here is reflected over the linear parent. And these points are reflected too, but they're non-real numbers, so we don't include them in our graph. So the quadratic and the square root, which they share a button on your calculator, they're inverses, which means the x and y values are switched, like y'all pointed out on the table. The graphs are reflections, not across the x or y axis, but they're reflections across the equation y equals x, the parent linear function. And I've seen that once in a while as a test question. So they reflect over y equals x. What do you think so far? Okay? So knowing this about square roots can help us graph them. So we're going to kind of go back to parameter change graphing. If you have a calculator, you can always type them in your calculator also. The first one, what kind of equation is this one? Quadratic. How do you know? It has a squared. Good. What's the minus 5 inside the parentheses do? Shifts it which way? Right 5. And how about the plus 3 on the outside? Up 3. Good. So they're giving me the vertex of a quadratic equation. So it goes right 5 and up 1, 2, 3. From here, I can just use that regular counting pattern. So I'm just squaring everything. So 1 squared is 1. Here's my buddy point. 2 squared is 1, 2, 3, 4. Here's my buddy point. 2 the other direction. 1, 2, 3 squared is 1, 2, 3, 4, 5, 6, 7, 8, 9. I can't quite get that one on my graph. It's up there. I kind of like knowing that it's doing something. Maybe I could just drag it. There we go. So let's see. 1, 2, 3 squared is 1, 2, 3, 4, 5, 6, 7, 8, 9, and now it fits. There we go. Okay, so we can fill out the table. You can fill out the table from the actual graph on your paper. So they're asking you, what's y when x is 5? So 3. What's y when x is 6? 4. Y'all tell me the rest. What's 7? Perfect. Okay, when they ask you to describe the parameter changes from the parent, they're just asking you to write right 5 and up 3. My domain. Is my domain going to change from the parent function that we talked about? No, it's still going up, and ever so slightly, it's going like to the left and right, so it's still going to be all real numbers. How about my range? Did my range change from 0? Yes. Where's the bottom now? 3. Good. So now we're going to graph a square root, and this is going to be its inverse, okay? And later on in the unit, we'll learn how to find the inverse algebraically by switching x and y and solving for y, but they're just giving it to you. See how it kind of looks like the opposite? The numbers look backwards. Okay, so let's go ahead and graph it. The parameter changes underneath the square root. Minus 3 goes which way? Right 3, and then the plus 5 goes, good. So we have right 3, up 5. So that's going to be the tip of our square root, where it starts, like the end that doesn't go to infinity. So right 3 and up 5. It's going to be right there.